First of all, I want to introduce myself. I'm Mari. I'm Oracle Certified Master and currently working as a Senior Solutions Architect at FlashGrid. And I'm Senior DBA at Liberty Bank and one more. I have been working for 9 years as a DBA, and in my career, I have been working for 12 companies, especially in parallel, so it helped me to gain a huge experience in a short time. I'm specialized in Oracle technologies. Also, I know Linux administration. I'm a blogger from 2010, and I'm sharing my experience about Oracle and Linux. You're welcome, Pablo. I recently have been, my blog has been entered in top 50 Oracle blogs recently. Today's session is about Oracle Exadata hardware architecture overview. We will discuss each hardware component in detail, its speed, its characteristics, and so on. But first of all, let's briefly explain what is Exadata and what key benefits we have there. It's high performance and high availability for Oracle database workloads. It's balanced hardware configurations. We have database server, storage server, and InfiniBand switches. We have one more, which is not written here. This is a Cisco switch. It's not written here because it's not customized for Oracle needs. It's just an ordinary Cisco switch. It's simple and fast to implement. It's highly complementary with clustering and parallel operations. And the partitioning and the Oracle real application clusters are highly recommended software options. Well, on the first picture we see, I'll try to take the laser. On the first picture, we see database server, also called database node. We will discuss its hardware details later, but because we see here some components I want to explain previously. So we have local drives here. Each local drive is a 600 gigabyte in size, and they are 10K RPM disks. We have USB drives here, USB ports, USB ports here. We have some LEDs. The first one is a locator LED. The second one is a service LED. So if it is amber color, then it means that our database server needs some service. So we should take care of it. We have OK button, OK LED here, and we have power button here. These four are fillers. You can remove the fillers and insert another 4 local drives with the same size and with the same speed. The next one is storage server. We usually call it cell node and cell server, and it has 12 disks, and I call them archive disks because Oracle calls it archive disks because it's 7.2K RPM disks, and here we see the disks. You cannot see here, but if we resize the picture, we see that there is written 4 terabyte in size. We have a power button, also LEDs here. We have USB ports, and we have flash drive inside, but it's not shown in front side. Well, I want to tell you one story. We purchased two couple of Exadatas recently, and there was 4 TB of disks. And after a while, for example, for about one year, we purchased another couple which came with 8 TB of disks. This Exadata was X52, both of them, but they came with different sized disks. So this can happen. Another core component is InfiniBand switch, which has 36 InfiniBand ports. It also has a USB port here and LEDs here for some indicators. Okay. This one is a hero in Exadata. This is flash memory card, which is located, as I said, in cell server here, but it's not in the front side. When you open up the back side of the, the head side of the cell storage, you will see the flash card. Well, X7 was released 1 year ago, and we have two types of X7. It's X7.2 and X7.8. Database servers and also storage servers. We will explain them separately. Exadata storage servers are flash equipped, and we have InfiniBand switches, as we already mentioned. We have a Ethernet switch. This is a Cisco switch. It comes completely pre-cabled, and it's easy to deploy. We should just plug in a power, connect to the network with your network administrator team, and run one command script to rebuild the Exadata, and you're ready to run the database. Here we see that we have database servers, we have a network, and we have a storage servers. In database servers, we have two types, 2-socket x86 server and 8-socket 86 server. The first one has 48 cores. In each socket, we have 24 cores. And its memory can be increased up to 1.5 terabyte DDR4 dynamic RAM. The second one is 4 times bigger and has 192 cores, and its memory can be increased up to 6 terabyte dynamic RAM. Well, the second part is a network, which is also the core component in Exadata. We have 40 gigabit per second InfiniBand internal connectivity. We use this InfiniBand connection between the nodes, between the storage nodes, and between the storage nodes in itself, and for the private connection and for exchanging global cache messages. For public connection, we have 25, 10, and 1 gigabit per second Ethernet ports on Exadata backside. And of course, when we are talking about 25 gigabit per second port, Ethernet port, we must consider that we also must have the same speed network switch, network hardware switch or router on network side for public network. And intelligent storage servers, we have two types, extreme flash storage server and high capacity storage server. The difference is that the first one only uses NVMe flash drives, and its maximum capacity is 51.2 terabytes. And high capacity storage server has 25.6 terabyte flash drives and 120 SAS drives. And when we are talking about the Exadata number of cores, we should consider that cell servers also has a cores and has its CPU and it has its memory. So, and most of the work is done on cell side. So here we have two socket servers. Each socket contains 10 cores, so totally we have 20 cores per cell node. Well, we see here database servers. As I mentioned, there are two types, X72 and X78. The first one is X72 and it's much more smaller than X78. I already explained the hardware for the first one, and I want to briefly explain here the hardware components of the second one, and we will see later in details. So we see here the fans. They are fans. Don't think that they are CPUs, because CPUs are located behind. So inside this fence, and these four are power suppliers. So X72 database server has Skylake CPUs, which is the keyword of Intel, and so we have Intel Xeon processors with 2.1 gigahertz and two sockets, as we mentioned, and each socket contains 24 cores, so totally we have 48 cores. And dynamic RAM is 384 gigabyte, and we have totally 24 slots for memory. But when Exadata came into our data center, we have 32 gigabyte memories, and they are 12 in number. And it can be extended up to 1.5 terabyte, but keep in mind that look at here. It says that 24 times 64 gigabyte can be 1.5 terabyte memory, right? What about this 32 gigabyte? We should remove this one and insert new 64 gigabyte memories, and we can fill all the slots, and we will have 1.5 terabyte. As I mentioned in previous slide, we have four 600 gigabyte drives in front of the database server. They are 10K RPM SAS disks, and they are hot swappable. And we can remove the fillers, another four filler, and add another 4 drives, and we will have 8 drives totally. But keep in mind that when here is a written hot swappable, it means that server should not be is not necessary to shut down to change the disk, but if this is a part of the operating system, then you will not be able to easily swap or change the disk. So non-OS disks, you can change it without shutdown. Well, this controller, because it's not a flash and it's just a SAS drive, SAS 3 disks, we have a disk controller. This controller comes with 2 gigabyte cache, and here is written that Oracle remote batteries. Even X6, they mentioning that there is no more batteries, which is confusing. It was confusing for me too when I read this one, because let me explain what the controller cache does for us. There are two types of caches for controller. Write-through cache and write-back cache. So write-through cache means that the data goes, for example, when a host tells the this controller to write information to the disk. This controller saves that information in a cache, and if this writes through cache and goes to the disk, and just after that return the host that write operation is completed. So it's quite safe because we definitely know that the data was written to the disks. But in case we are using write back cache, which is much more faster, because when a host tells to this controller to write the information to the disk, it is first written to the cache, and directly the message is returned to the host that the information was written to the disk. But instead of the disk, the data is written in a cache. So how do you think if the power failure occurs at the time and we have a cache, we have data in a cache, not in a disk, what will happen? I will answer myself here. You will lose all 2 GB of data, and 2 GB of data is too much for OLTP databases, of course, and for other databases, of course. And what happens here? We had the batteries before with this controller, which was making cache, not flash cache, but this controller cache alive until you power on the server. You may think that power failure should not occur if you have UPS, but UPS may handle some failures. And for example, if someone pull out the cable from the data center, yeah, the UPS will not help you at the time. And there are other cases in which cases UPS is not able to help you. So what the battery does, battery has some lifetime, for example, 48 hours, and it lets you turn on your server during that time, and the cache will be written after it started up to the disk. So it's flashed after startup. So when I read that Oracle removed the batteries, I thought that Oracle may just leave the write-through cache where the batteries is not necessary. But this is not so. Oracle changed the batteries with supercapacitor. Supercapacitor is much more reliable. It has a big lifetime, and it can quickly charge and discharge. So we have quite improvement here. And about the network, I will show you on a picture. The first one is two 1G/10G base T, so twisted pair Ethernet ports. They are located here. You see, I think. They are LOM based, so they are directly located on motherboard. It's not PCI. You should not use PCI card slot to install the module of 1G/10G port. And we have two 10G/25G Ethernet SFP28 ports. They are also LAN based, LAN on the motherboard means. What does 1G/10G means? It means that it can support both, but on the other hand, there must be 10G if you want 10G connection. If you don't have a 10G connection on your router or on your switch, you can configure your Exadata ports to have a speed 1G. The same here. And we have two 10G, 25G Ethernet SFP25 ports, but they are ports 8-in card based. So these PCI card slots are used for inserting the new module. This one is for InfiniBand ports, for InfiniBand connection. We have power supplier with a fan, a second power supplier with a fan. We have locator LED here, we have service LED, which is amber, and we have OK LED, which is green. I will explain what is a locator LED. Some of you may not know about that. From IORM command line interface or from the web interface, you can turn this light on. You can say to turn the light on, and you will easily find the server on a rack where it is located. That's why it's called locator LED. Sorry, locator LED. This port is IORM port. So for remote connection, you can connect to the database node or cell node, and even it is shut down state, you can start up through the IORM. This is 1G port. You can also connect to this port remotely. This one is USB ports, and this one is for serial connection. To connect to your, so the Exadata team first connect to the serial connection and rebuild the Exadata, and then this port is not commonly used, just for initial configuration and if the IORM is not working in such cases. Yeah, we discussed X72. Now it's time to discuss X78. It has 824 core. This is also Skylake CPUs. It's Intel Xeon processors, 20.7 gigahertz. And its memory, it comes with 3 terabyte of memory, and it's expandable up to 6 terabyte. Local disks are 2 and 6.4 terabyte. They are also hot pluggable PCIe drives. And network, we have 8 InfiniBand ports. QDR means the speed of the port. This is a 40 gigabit per second. These ports are located here, here, and here. All of them, all these one are PCI slots, and you can insert the modules, new modules here. This one is free, and this one also free, and you can insert new modules. You have 8 10G 1/10G ports. Here are 4, and another 4 is here. And we have SFP ports. The SFP ports are here. They look like that. This one are power suppliers. We have IORM ports 1, 2, and we have serial port 1 and 2. This one is a system A, and this one is system B. So this was the back side of X78. Well, we went to the storage servers. We have 2 types of storage servers. External flash storage server, which has only NVMe drives, and high capacity storage server, which has NVMe drives and also SAS drives. Each SAS drive is 10 terabyte in size, and they are 12 in number. They are located in front. And now in details. And processors, we have still Intel Xeon processors, 2.2 gigahertz, and they are 20 core totally. We have 192 gigabyte, and they are 60 gigabyte in size, and they are 12 memory kits. Drives are 8, 6.4 terabyte, and they are NVMe drives. What else? We have 2 or 150 gigabyte that's are for booting the operating system or rescue functions. No more USBs. Well, when we purchase X5 tool, it comes with a USB inside a motherboard of cell node. And we had the case that the USB became broken. It was faulted state, so we have to uh, remove this USB and insert the new one, and copy the operating system and make it bootable. The first bootable disk is the USB drive for cell in X5. I mean, not here. And because of it was located on a motherboard, we switched this cell down, switched off the cell, and then removed the USB. So some not necessary downtime was for the cell, I think. So that's why they are not using USB anymore. Well, we have two InfiniBand ports. Here you see these are InfiniBand ports. All of them are PCI slots, and you can insert the module here. We have serial port for especially used for initial configuration. We have IORM port here. We have 1G port down here. We have USB port and LEDs for understanding our cell is in a good state or good shape or not. We have power suppliers and the fans. And this was the back side. And high capacity storage server, 210 cores, the same, just the difference is with the storage. You have 4 times 66.4 terabyte flash accelerator PCIe cards. The same here with this controller, InfiniBand ports, the IORM ports, 1G port, and the serial port, and the power suppliers and fans. Well, this is our Exadata. You see in rack units, we have, you can start with a quarter rack, and you can have two Exadata. It comes with two Exadata X72 database servers and three high capacity or extreme flash storage servers. You can add up to 19 database servers and 18 storage servers. The size of the database server is 1 rack unit. As you see, this is 1 rack unit, and the storage server is 2 in size. So you must consider its size when inserting and identifying how much cell server can be there. You can place cell servers upper parts, but it's better for eyes to easily find your server if it will be down and the above will be database servers. Well, here is this InfiniBand switch. Between of them, there is a Cisco switch and another InfiniBand switch for internal connection. And in case one InfiniBand switch will go down, another will be for internal connectivity. Otherwise, there will happen eviction or your nodes will go down. Well, we see here that X78 is much more bigger. They are 5 rack unit in size than the previous one. In 8 rack, well, when you purchase 8 rack, it really comes with quarter rack. It comes with total quarter rack, just half of the resources are disabled. So you have 48 cores. In 8 rack and quarter rack, you have 3 storage servers, cell nodes, and half of the drives are disabled because you have an 8 rack. And half of the CPU is also disabled. There are 30 cores and such amount of flash, and if you choose external flash capacity, you will have such amount. So with quarter, you have double. With half rack, you have double than the previous one, and with full rack, you have double than the previous half rack. So actually, you start with a quarter rack and add database servers on your demand, and add storage servers on your demand. So you can increase your existing Exadata with adding several servers. What is expansion rack? Sometimes for some companies it's not enough to have such amount of storage, and in case you want, for example, applications to have some disk backups, historical or archive data, file data, logs, XML and documents and images, you have to buy additional cell servers, and for that you buy expansion rack, which only contains cell servers and there is no database node. So you save money for with not purchasing extra database node that is not necessary. With quarter rack, you have 2 InfiniBand switches here, and with a full rack and half rack, you have 3 InfiniBand switches. Well, about automatically opening service requests, Exadata is able to automatically open service requests when some failure occurs, for example, disk, flash, memory, or processor failures. But it does not directly mean that your Exadata must be located in must have a public network or something like that. For the purposes, you create another server, ACR manager. You install there an ACR manager, and it's dedicated for that purposes only. No other software must be installed there, just for security. And for each cell server or IORMs or other servers, you indicate a subscriber for traps, the IP address that you configured as a ACR manager. So when we purchased the Exadata, it came with a Platinum Gateway server that was located, but is located here in the upper part. This is just one rack unit size, and it has a public IP, and Exadata sends the information to the Platinum Gateway, and Platinum Gateway opens the SR if it is necessary and if there is a hardware fault. Well, 9 key features of Exadata storage. We have a Smart Scan. You're familiar with it, but I will just say several words about Smart Scan. It means that database sends a query to the cell node. Cell node makes more work using this storage indexes. Maybe we'll discuss later. And search the necessary information. Only the output that was necessary for database is sent to the database node. So most of the work is done on cell server. And cell is SQL aware, and it's quite smart storage. The next one is a hybrid columnar compression that reduces the number of blocks for compressed data. This is achieved by dividing the data into columns instead of dividing into rows. And when the data has the same type and there are too many duplications, the compression is very high. So the Oracle achieved the high compression using the new algorithm of dividing the data into columns. Well, IO Resource Manager, which I will discuss in my last slides, for prioritizing IO bandwidth based on database workload within a database between the resource groups. Smart Flash Cache and Smart Flash Lock are used for saving data in a PCI flash card. The flash cache is for data saving, and flash log is for redo log information to be saved as quickly as possible. Storage index eliminates unnecessary I/O. Well, I will show you how storage index does this one. Let me share the screen again. So you see the picture. I'm explaining here the storage index. So we have the table. We have a column here, cast level, which contains 1, 2, 1, 3, 4, and null. When you run a query several times, on cell node memory, there is created a storage index. That will create some useful information for you, not for you, but for Oracle. It tells that in this region means a disk region. In this disk region, we have minimum value 1 and maximum value 2, and there is no null. And another option is another component is contains minimum value 3 and maximum value 4, and we have null. For example, we are searching the ID cast level, which is equal to 3. What will happen? It will go to the first bucket and ask and check that this 3 is more than 2 maximum value. So it definitely not located in this region. So this region will not be read from a disk. And it goes to the next bucket, and we will see that minimum value is 3 and maximum value is 4. So the data should be located here. It does not necessarily mean that the data is definitely located here. In that case, it's definitely because it's in mean, but if it were, for example, here maximum 5 and we were searching 4, this 4 may still not exist in this region, but storage index still eliminates with unnecessary reads, like the first region will not be read at all. And the next one is Exadata storage server security, which is a SIEM level and database level, which means that you can restrict some databases from accessing the grid disks, some grid disks, but not to be confused too much. If the grid disk is belongs to one disk group, all disks, grid disks that belongs to this disk group must be accessible by the database. And write-back cache, I already explained write-back cache in this controller. The same is here. The data is written in a flash cache first, and then return the control to the message to the host that the data was written. So it is quite fast than the ordinary archive disks that I mentioned, which is in 7.2 K RPM speed. And adaptive scrub schedule. I will explain a little bit more about that. What is scrubbing? It recovers some bad blocks on a disks in case we have a mirror or we have a high redundancy. But this Oracle checks a block when it reads, and if we have too many blocks that are not read for a long time and they are corrupted, we do not know, and Oracle does not know about that. And in case the mirror fails down, what we have corrupted blocks, right? So that's why we need to run scrubbing periodically, and on ordinary databases, we are doing this by cron job or something like scheduler. Of course, scrubbing this performance perspective, it's not very good, but for having reliable data, you need to do such things. Well, you can also check the logical corruptions by IORM backups, writing the clause check logical. And Exadata has the schedule. It checks, it scrubs the disks every 2 weeks, and you can change it using CLI command line interface. So virtual machine clusters can be located on Exadata. This is not our topic today, and that's why I have just 2 slides about that. And I'm mentioning the InfiniBand network isolation. For example, domains and the virtual machines can access any of the storage cell. But if we are using PK, so InfiniBand isolation, just only several VMs are able to access the cell storage. So it can be useful in cases we are using PCI DSS so for security reasons. You can disable smart flash cache, you can disable smart scan or hybrid columnar compression, IO resource management, but you are not able to disable InfiniBand or some end-to-end tuning. What we have in ordinary database, this is a multi-tenancy in memory, real application clusters, data guard, partitioning, advanced compression, security, real application testing, analytical special, Oracle special, and management packs. But we have more with Exadata. We have offload SQL for storage, which I explained already. This one part is smart scan, that most of the work is done on storage cell. We have InfiniBand fabric, which is 4 gigabit per second, and we have smart flash cache and flash log for faster I/O. We have columnar flash cache. This is an extension of in-memory database that the cache, columnar flash cache, is saved on a PCI flash card. And we have hybrid columnar compression only available on Exadata. We have resource management, we have network resource management, so quality of service is used here. And we have memory fault tolerance, which means when you indicate a table or columnar partition or materialized view to be in memory, you can indicate a duplicate keyword, which makes a mirror on another instance, or you can indicate duplicate all that will make mirrors on all other instances. And in case one instance fails down, another, without rereading the data and reconfiguring the data again in memory, you have an additional copy in another instances. And my favorite one, this is Exafusion direct-to-wire protocol, which is quite good when you have global cache events. So what does it do? It's just an ordinary parameter or initialization parameter for database. You must set it before and restart the database, and you must have the same value for each instance. What does it do? It will not go through, so global cache messages will not go through the kernel. It will not go to the network layers, but it sends the information directly to the wire. So it's quite fast, and you don't have a CPU overhead here. And the last part is IO Resource Manager. Not just only IO Resource Manager is described here, but the distribution between databases, some memory, CPU, and IO. Well, it's integral software. IORM is an integral software. It's controlled by cell CLI command line interface. We have two types of resource plan, inter-database plan, and inter-database plans. Inter-database plan means dividing I/O between the consumer groups inside the database, and inter-database plan means dividing the bandwidths, I/O bandwidths between the several databases. I will skip this one, not so important. So while hosting multiple databases on Exadata, there is a risk that one database may eat all of the resources and stop others. So the shared resources are CPU, memory, and I/O. With CPU, we are using instance caging, as you are already using in normal databases. It's not necessary to have Exadata. You set the CPU count here. This is a number of threads, and you enable the resource manager. The last part is very important because otherwise the limit is not activated and you just have some initial value for parallel operations. So you can have your resource manager plan and set the value to your plan name. For memory, we have two types of memory, shared and non-shared, SGA and PGA. It's recommended when you have a huge amount of RAM to leave 20% of RAM for OS and 80% of for SGA and PGA. So the formula will be like that. 0.8 times total memory will be the database usable memory in gigabytes. And sum of total SGA max size will be 80% from there. And I recommend, and also Oracle recommends. Yeah, if you have any questions, please feel free to write in the chat, and I will try to answer. Okay, I will go on for now. When we have a huge memory, we can have swapping. That's why we must use huge pages instead of small pages and disable transparent huge pages. Transparent huge pages are dynamic huge pages that it's not good for databases, and it may cause some databases to restart or have not eviction. The huge pages is a parameter that is indicated in sysctl file, and the server needs to be restarted. So this is the number of pages, and the page size is 2 megabytes. So we have the formula. We add 2 for management databases and database which has also some SGA, and will take a huge page if it is allocated. So to have enough huge page for our databases, we have to set this number. And disabling transparent huge page can be done through the grubby in grub config, and this one your kernel. You can understand your kernel by grubby default config and what will be the output. You place it here. And from each database you run, use large pages only, and it needs to be restarted. So you will not have swapping because of SGA, but because of PGA you may still came across the swapping. So you need to set the following parameters accordingly. You have 2 parameters, aggregate target and aggregate limit. The limit is achieved by setting the PGA aggregate limit. So it must be the 20% of database usable memory in gigabytes. And this is the sum of total PGA aggregate limit. So all databases in sum. And IORM, which is only available on Exadata. What we have in the ordinary database, we have a resource manager, right? But with resource manager, you can easily allocate CPU because it has a scale as a percentage, and it's easy to understand how to allocate the percentage. But for memory and for I/O, it has only the upper limit. So it's not easy to identify how much I/O will be necessary for retrieving even one row from the table. You may restrict the sessions and the research consumer groups to have just 10 megabyte of I/O, but for returning the one row, Oracle may process 20 megabytes. So out of the limit, you may kill the session. So it's better to have percentages instead of the sizes of memory or I/O. So this can be achieved by IORM, which is only available on Exadata. Well, it can be done by several ways, but I will discuss one of them by setting DB performance profile with some value. For example, it will be easier to identify which database performance profile it is by setting database name here, and then using database profile name in the following plan. I will explain. So we have two databases, bank and HRDB. We allocate 70% on the first level for bank database and 30% for HRDB. And for example, HRDB may not use 30% on the first level and may leave some additional remaining IO that will be used on a second level by bank with 100%. And if first level and second level does not use some amount of IO on the third level, HRDB will use 100%. And on the fourth level, we allocate the resources for other databases. These other databases will be when you create a new database and you have not indicated an NDB performance profile for them. They will come to this restriction. So on the first level, when bank and HRDB does not have some additional resources that is not necessary, will be taken by other databases. This must be run on each self-server separately. And another one, you can also restrict resource consumer groups inside the database by the following way, using the category plan. You indicate the administrative allocation is 25% and others 75%, and you go to the second level and the third level and so on. You can have several levels for allocating resources. Well, thank you for your time, and if you have questions, please feel free to ask and I will try to answer. Otherwise, you can send me an email with your question on this email, and I will be fast to answer your questions